Thank you so much. Welcome, dear guests. Actually, I plan to talk a little bit about the global warming, the emission issue, the rising temperatures, but look at the weather, it puts me in a hard condition. But anyway, it's warming. Believe me, the IPCC report says that. So let's look at the details, what's going on, and the plan for Erdemir and İstemir, how the net zero carbon roadmap will go on. As you know, the steel industry accounts for 7 to 9% of the total emissions in the global total emissions. This is mainly due to the use of the coal in integrated steel plants and also due to the energy generation in thermal plants to use in the production of steel. And it accounts about 75% of the all energy need in the industry. And the problem about using coal is that it emits CO2 because in nature you cannot find the iron ore in pure form. It has a bond with oxygen. So the carbon content in the coal is used to make the reduction process and also gives energy. This is important. And there are various greenhouse gases. The CO2 is not the only one. There are other types like methane and other greenhouse gases. But the issue about the CO2 is that there are two main big points about it. When you emit it, it hangs in the atmosphere for very long times. It goes up to 1,000 years, actually. And the second problem is that the total amount of CO2 emission is the biggest amount of greenhouse gases between them. So by saying these generic information, as steel producers, we have to do something because we are emitting a lot of CO2. Today, I will present you the net zero emission roadmap of Erdemir and its subsidiary company, İstemir. Meltem already mentioned the Erdemir is located at the north side and the İstemir is located at the south side. They are both integrated steel manufacturers. And at the beginning of this year, in January, we have already announced our roadmap and set the targets for 2030, 40, and 50. Net zero target for 2050. We took it serious. There are a lot of details. I will just dive into details how we can achieve those targets and the projects behind them in my presentation. But before going to my presentation, let's see our short video about net zero roadmap that's already put in our website. Maybe you can see it on the outside also. Let's watch first it. Okay.
The green journey of steel towards net zero carbon. Our planet is at risk due to the climate crisis and global warming. In recognition of this imminent risk, 197 nations stand united with a shared objective to cap the rise in global temperatures at 2 degrees, with an ideal target of 1.5 degrees relative to the pre-industrial era. In 2015, the Paris Climate Agreement was signed, and numerous countries committed to collectively act against global warming. As industry leaders, both in Turkey and globally, Erdemir and İstemir have developed a roadmap for green transformation, setting the course for a brighter future. Our journey is guided by a long-term vision. Integrated steel production worldwide has been using similar methods for centuries. Iron ore is reduced to liquid iron through carbon in coal. Based on the reference year 2022, we aim to reduce our emissions 25% by 2030, 40% by 2040, and achieve net zero emissions by 2050. What are our short, medium, and long-term actions to achieve these goals? Primarily, we are taking systematic steps to reduce greenhouse gas emissions through energy efficiency measures in our processes. We will meet electrical energy requirements in our facilities from solar power. By establishing a scrap collection and processing center, we will increase the scrap share in our steel production, reducing emissions per finished product. We will gradually increase the use of biomass instead of fossil coal in our production. In addition, We will also adopt electric arc furnace technology in our production. In the medium term, we will implement the more environment-friendly DRI technology with natural gas to achieve our goals. In the future, we will power our DRI plants with green hydrogen instead of natural gas. We aim to implement carbon capture and storage technologies. We will firmly progress towards the net zero carbon goal by 2050. We will work continuously for a sustainable future.
Let me make all those different projects, all various types of emission reduction, let's say, projects a little bit clear. What's behind them, how we plan to implement them in terms of its order, and etc. You see, at the beginning of the video, then we can go to the slides. At the beginning of the video, we have already mentioned that the carbon currently in our process steps is needed to make the reduction. And it is not a very new thing because through the ancient times, the carbon has been used used as the primary reduction agent. And the process has improved already, but nowadays we have to find some alternative ways to make it possible. Let me go to details first about what is the emission currently in different production routes that's used in the world. These numbers are taken from the versatile association values. Last year they have given the report about CO2 emissions. There are mainly three types of production flow in the world, the main production types. The first one is ours, actually in Erdemir and Erdemir. We are using blast furnaces with the BOF facilities. The average scope 1 plus scope 2 emission is about 2.2 tons per crude ton of steel. If you use natural gas in the DRI facility and put an electrical arc furnace behind it, the emission values decreases really to half level. It's about 1 tons per ton crude of steel. So there's a huge difference between them. And lastly, if you are using an electrical arc furnaces and scrap, the emission is already down to 0.5 tons level. Because it is scope 1 plus scope 2 emissions, because our roadmap is focusing on scope 1 plus scope 2 emission reduction. What we are saying with scope 1 and scope 2, this is a very generic information, but we have to deal with our direct emissions, and also we have to deal with our indirect emissions, the emissions coming from the electrical grid, because the electricity should be also green to make it possible to reduce the whole emissions. The scope 3 emissions is also very important, but at the very beginning of this journey, we have to put the priority to scope 1 and scope 2 to make it a little bit more concrete, actually. When you look at the reasons why that much of emission, 2.2 tons of emission is coming, the main reason is from coal. In an integrated steel plant, the main source of the carbon is coming from coal. It's about 84%. And the rest is divided to different carbon content materials, natural gas, electricity from the grid, and also other materials that we have used during the production. And taking the base year, 2022, we plan to decrease our emissions about 25% at the end of 2030, and also it will go its way, and at the end of 2040, it will reach to a decrease of 40%. And from then, we plan to make it net zero about 2050. This long roadmap is very related to the technological developments and its application in the industry. So I will make it clear with the projects and its details why the logic behind that 25, 40, and net zero is going according to that different years. The first action is coming from, the main action is coming from the electrical arc furnaces. In our plan, we are looking for investing in new arc furnaces, both in Erdemir, it's about 1.4 million tons, and in İsdemir, it's about 2.5 million tons capacity. With the addition of those new electrical arc furnaces, the reduction for each facility will be about 25 to 17%. It changes accordingly. So the very recent plan before 2030 is to apply the electrical arc furnaces in our integrated manufacturing area. By the way, just a small information, this arc furnaces does not use only scrap. We have hot metal from our blast furnaces, and our electrical arc furnace technology will be chosen accordingly to handle with different kind of materials. So it's a little bit different when you compare to a classical arc furnace. Secondly, we have been working hard about use of energy efficiency projects. There are various types of projects that we are currently going on. The turbo generators, coke, dry quenching systems, and also steam boilers. They all give us some improvements in our energy efficiency, and it accounts about, you see, 3% level of reduction in terms of per ton of crude steel. Another big investment is coming from the solar power plants. These are very big plants and the biggest investment announced in Turkey in this area. You see there are some cities here, Van, Malatya, Çorum, Diyarbakır, Şırnak. These are the eastern part of the Turkey. We have purchased very big fields and announced that projects. When you look at the numbers, the peak power is really high, 400, oops. Let me take it back. I'm sorry. When you look at the peak powers, it's really at the very high amount value, the 424 and 530. These are huge solar power plants, and it will affect our Scope 2 emissions. Currently, we know that the CBAM regulations account about the Scope 1 emissions that we have done, but we have been getting ready for the inclusion of Scope 2 since we are producing in Turkey. And we also talk with France in the European Union in that commissions, and the Scope 2 is coming at a much lower voice, so we have to do something for that also. And the fourth action is coming from the biomass usage. In an integrated steel plant, there are various points where you use coal, actually. In the coke making plant, for example, you can use biomass in the coke plant. When you are making the coke plant, you can replace some of the coal with biomass. This is one of the area, a big improvement area. Another use is the PCI application in the blast furnaces. If you can replace the PCI with the biomass, with some process before actually, it can replace the classical coal there. So by following those different production steps, replacing as much as possible with biomass and biocoal obtained from them, you can make a huge reduction in terms of your Scope 1 and Scope 2 emissions. Actually, Scope 1 emission, about 10%, 11% level. This is also very important. And I am not saying this in theoretical way. We have already built up a pilot plant, pyrolysis plant in the facility to make the testing. The R&D department is working hard on it. So these are the numbers that's calculated according to the potential of the biomass reservoir in the region at the north part of Turkey and at the south part of Turkey. And now I am talking about a little bit, let's say, actions that's going beyond 2030. because it is very related with the resources. You know, in Turkey, we don't have the natural gas resources. We have found some in the Black Sea region, but when we are talking about a continuous supply, we need to buy it from outside. So please take these actions beginning from the 2040s. We have planning to put 2 DRI facilities, both one in Erdemir, one in İstemir, and it will be about 2 million tons capacity that will be added. But at the first sight, it's much more possible to make it work with natural gas. It is not easy to make it work. We don't make a prediction like that, but at the first sight, we will use the natural gas to make the production because it just decreases the emissions at the half. And we also expect to make it work. We will choose the technology accordingly to work with the green hydrogen also, the DRI facilities. Because if you make to work a DRI facility with the green hydrogen, it's possible to reach very close levels to net zero. And accordingly, in Turkey, our energy ministry has announced its green hydrogen strategy. So when you look at the years and the capacity, electrolyzer capacity targets, it's very complicable with our, it's very in compliance with our roadmap. Beginning from 2035, some capacity of electrolyzers emerging, and the cost will decrease accordingly. So we expect to make it possible towards the 2050 to change the natural gas to green hydrogen in the facilities. But anyway, some of the blast furnaces in the industry should remain in the play because it has an economic life. We have new blast furnaces in the early ages. We have invested them, and some of the production will be coming in the blast furnaces, and there is emission, there is CO2 emission. But at the same time, we have been following the technologies of carbon capture and storage. And with the emerging technology at those areas, the emissions that we cannot avoid during the process is expected to captured and stored in a way without giving to the nature, actually. These technologies are not just for steel industry. There are various industries, cement industry, other industries should use that kind of solutions because they cannot avoid CO2 emissions too. So our last part, unavoidable process emission part, will be captured by those kind of technologies. So I hope that I make it clear a little bit the numbers behind them and how the chosen practices, the emission reduction practices will affect those emission figures of our companies. Thank you so much for listening to me. I hope you enjoyed. Thank you. By the way, do you have any question? I can also take it. Please.
So thank you. I praise again your commitment to sustainability. Seems huge work. So a couple of questions. First one, I skipped to ask Mr. Raffaello because I think Europe may be more advanced in the terms of demand on green steel. How do you see the demand on green steel from customer side? I mean, we are all trying to cope with the regulation, Paris Agreement. There is like some enforcement to switch into green. But do you guys in Turkey, you know, and in your export markets, I mean, apart from EU, apart from the automotive customers who are advanced and they require green steel products, do you think that there is a demand and customers would pay for you back a little bit of your investment? This is my first question. And the second question, do you know a number by heart if today we are going to put a plant that is DRI based, let's say natural gas, 1 million ton, for example, let's say, to have economies of scale, and another mill of 1 million ton of DRI using green hydrogen, not natural gas, and we compare it with the 1 million ton of classical investment. Do you have numbers by heart? Thank you.
The green steel demand is a very important issue. I am not the expert of those markets and I don't have those detailed numbers, but I know the problem. The biggest manufacturers of automotive and other big industries demand for, they are saying they want to buy, please be compatible with our own plans. As a supplier, we have to go with them. But the issue of the green premium in terms of prices, because the costs are rising accordingly, as you can imagine, it is not an easy thing to comment on. We know that the customer side may, the new generation is giving importance to this subject, but in order to make some concrete and specific comments, I don't have those detailed numbers. There are various articles writing in different manners, but it's an issue. I think that it will be settled down in the coming years. But new generation expects from their appliances in the house, the washing machines, the cars that use. So with the help of the regulations, we have to talk about regulations because we cannot give every law to demand side. It is not possible. But with the help of those regulations, especially coming from the European side, that market will also grow, I guess. In terms of numbers, the investment amounts about natural gas working DRI plant and hydrogen-based DRI working plant. I think if you choose at the beginning the correct technology, there will not be so much cost because the selection of the technology is important. Some of the current technologies in the market can also handle with green hydrogen if you can find it at an affordable price right now. They can work with it. We know that. But in terms of technology selection, there are other details also. So it is not just an issue with natural gas and hydrogen selection. It also some pros and cons about the technology and its efficiency and other issues. Thank you. Any question? I think it's close to lunchtime. Thank you so much.